Hello, welcome to Anatomy and Physiology, Unit 2, Blood. Today we're going to start with blood and blood vessels, then we'll go into blood transfusions. So what is blood made of? It's particles suspended in a fluid called plasma. And when you use the centrifuge to kind of spin everything into the right components, plasma makes up about 55% of our blood. Then you have white blood cells, and then the platelets, or not the platelets, the red blood cells make up the other larger portion. All right. So red blood cells transport oxygen around the body. They contain what's called hemoglobin, which combines with oxygen. There is no nucleus in here, which allows for more hemoglobin. And they're small shape and size, which gets you a larger surface area to volume ratio, which makes it ideal for efficient gas exchange. So if you have an example, a cube of sugar. It's a solid cube of sugar. It has a larger surface area to volume ratio because it's packed tight. So it will take a long time for that to break down. With the red blood cells, you don't have that because they're no nucleus. They're maximizing every bit of space they have. And so it wouldn't take much to break them down if we were talking about breaking them down. White blood cells are the cells of the immune system, which help to remove pathogens. They're very flexible. The most common one found throughout the body is called a macrophage. So it's a big cell eater. Phage means cell eater, cell destroyer. What they do is they will engulf. They'll reach around and engulf the bacteria or whatever the pathogen is and destroy it. Then platelets, those are small fragments of cells. They've broken off from larger cells in the bone marrow, and they're very important in blood clotting, and we'll see that when we talk about transfusions and some of that as well. Interesting point on the red blood cells is that they are trying to use them, and I don't know how far they've gotten on this. They're trying to put markers, white blood cell markers, on the red blood cells. So this is beneficial for HIV, and because HIV attacks the white blood cells. So if you put those markers on the red blood cells, which have no nucleus, the virus goes in there and basically dies. It can't recreate itself like it does with the white blood cells, which have nuclei. The other kind of cool thing is there's a family called the Blue People of Troublesome Creek, and you might want to check them out. What happens is they have what is called methylhemoglobinemia. And if you said that 5 times fast, you wouldn't even get through the first time. But these people are deficient in iron. So the hemoglobin can't bond with the oxygen because it needs that iron component. So they're getting less oxygen. And in higher altitudes, they actually have a blue cast because they're, missing the oxygen. And then if they get stressed or cold or, anything like that, with the Blue People of Troublesome Creek, though, you also had you had the founder effect because some guy came and he had it and he intermarried, and that whole group is just cousins marrying uncles or whatever, you know what I mean. Anyway, it's kind of interesting. All right, so now we're going to match each blood cell component to its function. So red blood cell, does it engulf the pathogens? Is it a fluid? Does it carry oxygen? Does it play an important role in blood clotting? It carries oxygen around the body. White blood cells, do they engulf pathogens? Are they a fluid? Do they play an important role in blood clotting? No, they engulf the invading pathogens. Your white blood cells are your body's defense against disease. Platelets, we'll be talking about how they play an important role in blood clotting. And then your plasma is actually the fluid that carries the other components. Yay, we did well. Okay, so now we also have blood vessels. We have arteries that take blood away from the heart and veins that bring blood back to the heart. So the arteries carry the oxygenated blood and the veins carry the deoxygenated blood. And then you have capillaries to allow for that gas exchange. So here's your vein, shows you blood going to the heart. It has valves like in your heart, semilunar valves, so the blood forces them open, then when the pressure releases, those close again, so you don't have backflow. So the flow of blood's not going backwards in the body. This entry is called the lumen. Now your artery is going away from the heart to the rest of the body. It has a really thick wall compared to the veins. And then your capillaries carry blood to the body cells. The capillaries are very thin, like I said, allowing for gas exchange. Sometimes shortcuts are needed too, so this would also be called a shunt. Okay, so which blood vessel do these statements relate to? So it has a large lumen. That would be the artery probably. Carries blood at high pressure. Has thin permeable walls, carries blood away from the heart, carries blood to and from the cells. That might be wrong. Has thick and elastic walls, contains valves, carries blood towards the heart. Okay, so carries blood away, thick elastic walls, carries blood at high pressure. The vein has a large lumen, because remember that was the opening. Carries blood towards the heart, contains valves. Then the capillaries carry blood to and from the cells, and they have thin permeable walls. So here's a little video on how gases move in and out of the blood. It does take place within the alveoli in the lungs. The oxygen and carbon dioxide move between inhaled air and the bloodstream by a process called diffusion. So stage 1, when air is inhaled, the amount of oxygen inside the alveoli increases, and the concentration of oxygen in the lung becomes greater than deoxygenated. So stage 2, the oxygen molecules will diffuse across the lining into the bloodstream of the capillary, where they bind with the hemoglobin in the red blood cells, and this is called oxyhemoglobin, so oxygenated hemoglobin. Then the body will produce carbon dioxide, which is transported in the blood plasma. Remember, it's a liquid. It carries a bunch of different things. And this process, though, causes the concentration of the carbon dioxide to rise and become greater than in the lung. So you've got these opposite reactions going. This also allows or aids in the transport of the oxygen and the carbon dioxide in the alveoli. Carbon dioxide dissolved in the blood diffuses from the capillaries into the alveoli, where it's exhaled. So you got a lot of cool stuff going on here, and it has to do with the pressure gradient as well that allows things to move at certain times. All right, so blood clotting. So you've got a wound, cut, whatever. The blood's going to want to clot. This is to help reduce blood loss. The idea also is to keep pathogens from entering, and then it also helps form the framework for repairing the damaged tissue. So your platelets, they're sticky, kind of like Spider-Man's spiderweb, right? They release chemicals that will start a ton of different reactions going on, and you get a network of fibers that trap blood, cell, and debris, and helps form a clot. So it basically builds up a barrier there to keep everything out as fast as possible. We don't want pathogens entering. Blood clots normally occur at the site of a cut. Occasionally, clots will arise within the blood vessels, and that's very dangerous. So if it obstructs the flow of blood to an organ, it can cause damage to the organ. It can cause death of the organ. There's so many different things. So people that are a little more prone to blood clots take anticoagulant drugs. Some of these are warfarin, heparin, and aspirin, and they can be taken when a person's blood clots too quickly, or like we said, clots somewhere else within the body, in the blood vessels. So these drugs basically reduce the ability of the blood to clot. Vitamin K, alcohol, green vegetables, cranberries can also affect clotting. Hemophiliacs actually need vitamin K to help their blood clot. And so you got a couple things, different things going on there. I don't know how many of you heard of warfarin and heparin. Those are very old school anticoagulant drugs. Aspirin, of course, is over the counter. I don't know how much aspirin it takes to do that, but if you're taking aspirin regularly, you probably are thinning your blood, which is bad. You should probably double check and see how much you're supposed to be taking and for how long. All right, so let's talk about blood transfusions, okay? Blood transfusions involve taking blood from one person, giving it to another. They are used to replace blood lost in accidents, after surgery, to treat blood conditions. There's a ton of different uses for it. Hospitals will store a large amount of donated blood, so they have it on hand. It's regularly donated by thousands of people around the U.S. So the American Red Cross obtains, transports, and tests blood from donors before it's used. Interesting thing is, here we have a blood drive twice a year. And there were a couple people that donate blood fairly regularly at other places, and so their blood was not good. They'd donated too recently to be used for the blood truck to allow them to donate blood. Now, cells contain markers on their surface called antigens, so antibody generators, means they trigger a reaction if they're not where they're supposed to be. Red blood cells contain either antigen A or antigen B, and these are basically the setup for the grouping of the ABO blood system. So if they don't have either antigen A or antigen B, then they're considered O blood type. So blood groups can be classified by the presence or absence of these antigens. So blood group A contains antigen A, so it will clot if you give it B blood. Blood group B cells contain antigen B only, so they will clot if you try to give it A blood. Blood group AB contains both antigens A and B. That's actually a better blood type, even though it's rare. And then blood group O does not contain any antigens. Okay, so blood group O has no antigens. Blood group A has antigens. Blood group B has B antigens. And blood group AB has A and B antigens. So blood group AB can take any blood type. It doesn't fight any of it. Blood type B has anti-A, therefore it only takes antigen B. Anti-B means, this is just an easier way to remember it, anti-B, so if you're anti, you're against things. So anti-B means it has antibodies against B blood. It can't take B blood. And then blood group O has no antigens, but it does not like anti-A and anti-B blood because it's the universal donor, so it can be given to anyone. But because there's no antigens in it, your body will fight everything else. So here we go. Blood group O can receive O. Blood group A can receive A and O because A doesn't have any antigens to trigger a reaction. Blood group B can receive B and O because it doesn't have any antigens against O, or O has no antigens to trigger a reaction. AB blood can take all groups. So like I was saying before, if a recipient's anti-B antibodies come in contact with blood cells containing anti-B, antigen B, this will cause clotting. So it affects blood donation as well. So they usually type you when you give blood. So a person with group A blood can only receive blood group A or O because these don't have B antigens. It can get a little confusing. Just know that if you've got type A blood, you can't take type B. If you have type B blood, you can't take type A. AB receives everything. O can donate to everything because it has no antigens on it. All right, so let's try this. Blood group O, no antigens, antibodies, anti-A and anti-B. It can receive O. Who can it donate to? It can donate to everyone. Blood group A has antigen A, so it has antibodies against B. It can take A and O, and it can donate to A and AB. B blood group has antigen Bs, has anti-A antibodies. It can receive B and O, and it can donate to B and AB. Blood group AB has antigens A and B, has no antibodies. It can take all, and it can donate to AB. So we were correct. Blood can be categorized using what's called rhesus blood grouping. They just found this out using rhesus monkeys. That's why it's called rhesus blood grouping. It's also called Rh factor, and that's the positive and negative portion of your blood. So individuals either do or do not possess the rhesus antigen on the surface of their blood cells. So those with rhesus positive or positive blood, and those without will have rhesus negative blood. So those with the antigen will be positive, those without will be negative. And that blood grouping is used alongside the ABO. So with group A blood, you can be A positive or A negative. Definitely important this type of blood grouping is considered during transfusions because anything that's not a positive for positive blood, negative for negative blood will cause clotting.